everybody at home? Can I get a thumbs up that you hear me and see the board okay? Awesome. All right, everybody here is we're good? Okay, so guys, we are now done with chapter 4 and we are moving into chapter 5. However, in years past, there's a lot of exponent usage in chapter 5. So a lot of times it has really helped before we actually start chapter 5. Just take a few days and review your exponent rules. Hopefully you remember them. You've done them in Algebra 1 and you've probably used them since. But I'm telling you, in the years where I have skipped the review, I feel like it has been detrimental to the students. So hopefully we'll take the next few days, just review these rules so that you remember them, they're fresh in your mind, and you don't have to worry about messing anything up, all right? So I apologize if you remember all of those rules, because this is nothing new, but just bear with me for the next few days. We'll probably take a quiz on just our exponent rules on Friday, and then we'll start chapter 5 Monday, okay? All right, so just take it all in. Let's make sure we know what we're doing with our exponents. All right, so let's go back to basics. If I give you the expression 5 to the third, 3 is the exponent or power in this expression. And then 5 is called, does anybody remember what the 5 is called when you put the exponent on? I'll give you a hint, it starts with a B.
Base.
The base. The 5 is the base. Okay? So in the expression 5 to the third, the exponent tells you how many times to multiply the base by itself. So 5 to the third literally means 5 times itself 3 times. 5 times 5 times 5. So guys, the number 3 never physically appears anywhere in this problem. He just tells you the number of 5s you should be multiplying together. So 5 times 5 is 25. 25 times 5 is 125. So that's the answer to 5 to the third power. Does anybody know what the biggest, most common wrong answer is to 5 to the third? 15. Every year, people want to say it's 15. And I don't understand it. I really don't. Because if you think this means 5 times 3, I don't know what math teacher you ever had that wrote 5 times 3 that way. If I wanted you to do 5 times 3, I'd say, hey guys, what's 5 times 3? Or I'd say, hey guys, what's 5 times 3? Or I'd say, hey guys, what's 5 times 3? We've never shown multiplication between 5 and 3 written that way. So I have no idea where it got stuck in your brain that means 5 times 3. But that is the most common wrong answer. And guys, it happens all the time. Now, when we start doing the exponent rules, I can see why you would easily do that. But you have to remember that 5, a base, to the third power is 5 times 5 times 5. The amount of times I have gotten quizzes back where students tell me 3 squared is 6 or 4 squared is 8. No, it's not. It's 9 and it's 16. So please be really, really careful. It's easy to make these silly mistakes. All right, so the exponent tells you how many times to multiply the base by itself. That's how exponents work. So guys, in these problems, I just put a little note. There's going to be exponents. There's going to be bases, and there's going to be numbers. The numbers are different than the exponents and the bases. The problem itself tells you what to do with the numbers. But these rules tell you what to do with the exponents. And the base always stays the same. All right, here we go. Let's do rule number 1. And guys, I apologize. I am going to drag this out a little bit. I am going to make us develop the rule first, see where it comes from, and then we'll use it. All right, so the rule number 1, and I say that there are 5 total rules. 3 of them are your main rules, and then 2 of them are like fix-it rules. All right, we're going to try and get through the first 3 rules today, the main ones. All right, the rule number 1 is the product of powers rule. So guys, product is multiplying. This is a multiplying problem. What do you do with exponents in multiplying problems? All right, so guys, look at example 1. Let's say they asked you to take x to the third and multiply with x to the fifth. Let's do it the long way and see where the rule comes from, even if you remember it. Guys, this literally means x to the third is x times itself 3 times. And then you're going to multiply it with x to the fifth, which literally means x times itself 5 times. So in reality, how many times do you actually end up multiplying x by itself? You end up doing it 1, 2, 3, 4, 5, 6, multiplication 8 times. Well, guys, if I multiply x by itself 8 times, that is x to the 8th power. So what would have been a quicker way to get to x to the 8th as our answer instead of writing all that out? What could I have just done with my exponents? M. So the rule says in a multiplying problem, when you are multiplying the same base, and I was, they both had a base of x, the base stays the same, and you add your exponents. So that's rule number 1. If it's a multiplying problem, you will keep the base and you will add your exponents. All right, well, guys, look here. Let's say I asked you to multiply 2y to the 4th with 6y to the 3rd. The beautiful thing, guys, none of these problems have adding or subtracting in it. So none of them have this distribution that we have to do. It's straight up multiply. And we know the order that we multiply doesn't matter. 3 times 5, 15. 5 times 3, 15. So guys, I can multiply this in any order that I want. So just for this example, let's rearrange it. Let's do 2 times 6 times y to the 4th times y to the 3rd. Let's put it in a nicer order. So what you end up doing in this problem is 2 and 6 are numbers, y's are bases, and 4 and 3 are exponents. So the problem says multiply. So multiply your numbers, 12, keep the base the same, and what do we do in a multiplying problem? We add our exponents. 4 plus 3 is 7. So it's 12y to the 7th. So you end up multiplying your numbers, keep your base the same, add your exponents. All right, look at example 3. A lot of students get thrown off when they use number bases. So guys, in this problem, don't think of 4 as a number. Think of it as a base. So this is 4 squared times 4 to the 3rd times 4 to the 1st. It's always assumed to have a power of 1, right? So the base, when we're multiplying, it's all the same. So the base stays the same. We add the exponents. 2 plus 3 plus 1. It's really 4 to the 6th power. A lot of students, they want to start multiplying their 4s. 4 times 4 is 16, and then 16 times, no, it's the base. The base stays the same. You add your exponents. Now you can ask your calculator, what is 4 to the 6th power? And it's a pretty big number. It's 1096. Now guys, if these were x's as the base, we would be done at x to the 6th. I don't know what the base is. But if your base is a number that you know, you can ask your calculator to figure out that final answer. You can take it one step farther. Are you guys okay? Hopefully this is easy, right? Nice and review? Okay. So look at this one. This is what your homework's going to look like. They're going to ask you to take this and multiply it with that. And again, notice, guys, there's no adding, there's no subtracting. It's straight up multiply. So go ahead, multiply it in any order that you want. Let's multiply our numbers. So -3 and -7 are numbers. Let's multiply them. It's 21. Now we'll multiply our x's, but what we really do is keep the base the same and add the exponents. So it'll be x to the 1st times x to the 5th is going to be x to the 1 plus 5, and that's 6. Now let's multiply our y's. So I can do it in any order, right? I just didn't rewrite it. And then it's going to be y to the 4th times y to the 9th will be y to the, how many total times do you multiply y by itself? 4 plus 9, 13. And you're done. Multiply your numbers, keep your bases the same, add your exponents. All right, this problem is just all jacked up, guys. Now you're just multiplying 3 things together. But again, notice, there's no adding and subtracting. Guys, they started throwing pluses and minuses in here, we'd be distributing our life out. We'd be foiling away. It's just multiplying. So let's multiply in any order that we want. Let's multiply our numbers, which are 3, -5, and 2. Let's multiply them together, get -30. Right? 3 times -5 is -15, times it by 2, -30. Now let's do our x's. It'll be x to the 2nd power, 1st power, and 3rd power. 2 plus 1 plus 3 is 6. X to the 6th. Now let's multiply our y's. Y to the 4th times y to the 6th times y to the 1st. It's going to be y to the 4 plus 6 plus 1, 11. And then last, our z's. Let's multiply our z's. Z to the 1st times z to the 7th times no more z's, just means we only have 2 to do. 1 plus 7, 8. We're good? First rule's okay. Again, I hope it's easy. Again, but I feel like when I don't review this, it doesn't go well. Guys at home, can I get a thumbs up that everybody remembers rule number 1? Everybody's good? Awesome. All right, let's go to rule number 2, although I'll have to pull this in. So the rule says, if it's a product, a multiplying of powers problem, then when multiplying the same base, we add our exponents. Guys, I wish it was a multiply problem. You multiply your exponents. It's just not the case. It's not how it plays out. It's an adding situation. All right, let's do rule number 2. And again, I'm going to make you see the rule first, and then we'll use the shortcut. All right, rule number 2 is your quotient of power. So it's basically when you're dividing bases, okay? Because quotient's just a fancy word for division. Let's do it out and see where the rule comes from. Let's say it's asked you to take x to the 6th and divide it by x squared. Well, guys, the long way says this is x times x times x times x times x divided by x times x. Well, PEMDAS says when multiplying and dividing are the only operations involved, you can do multiply or division. So let's divide first. Guys, x divided by x himself is 1. They're gone. They cancel out. We don't have to write 1 in the problem. It doesn't change anything. This x divided by that x is 1. They cancel out. So in reality, you're just left with x times itself 4 times on the top, which is x to the 4th. So can you see a quicker way to get to your answer with 6 and 2 ending at 4? Yeah, I'll subtract them. And look where it ended up. You take the big exponent, you subtract the little exponent, and the answer always ends back where the bigger exponent was. So since the bigger exponent was on top, our answer ended on top. Because watch what happens if it was the reverse. What if it was x squared divided by x to the 6th? Then it would be this. So now cancel, cancel. Now look where the leftover are. Now the leftover are in the bottom. The top is empty, but we always put a 1, because remember they kind of divided to 1, over x to the 4th. So look what happens now. Quicker way, still subtract your exponents, but guys, you don't want to create a negative exponent. So take the big exponent minus the little exponent and put it back where the bigger one was, because that's where the leftover will be. The leftover is always going to be where the bigger exponent was. Okay, so the rule says when the base is the same and we are dividing, we're going to subtract our exponents. Big minus small, put it back where the bigger one was. So guys, 4 to the 8th divided by 4 to the 5th. Remember, 4 is not a number here. 4 is a base. So the base will stay the same. What did we just learn we can do with our exponents in a division problem? Subtract. So the big exponent is 8, and we're going to put it back on the top where the bigger exponent was. So it becomes 4 to the 8 minus 5 on top, which is 4 to the 3rd. And again, because your base is a known value, we can ask our calculator, well, what is 4 to the 3rd? 4 times 4 times 4, 64. So you can always take the ones with a value as the base one step farther. If those were x's, we have to stop at x to the 3rd because we don't know the base. All right, look here. Guys, this is a division problem. Notice how there's no adding and subtracting. It's straight up multiplication, multiplication, division. So let's divide. Let's divide our numbers. So 10 and 2 are numbers. So the problem says to divide. So divide. What's 10 divided by 2? That's 5. That's a whole number. Where do whole numbers go? They go on the top, right? Because technically it would be 5 over 1. So as long as you get a whole number, you put that number on the top. Now let's do our variables. So the bases are the same. We can subtract the exponents and put it back where the bigger one was. So guys, x to the 7th divided by x to the 5th. 7 is bigger, so our answer will go back on the top, and 7 minus 5 is 2. So x squared back on the top. Let's do our y's. Y to the 6th divided by y to the 10th. 10 is bigger, so 10 subtract 6 is 4. Put it back on the bottom. And then last, guys, the z's. This is z to the first power divided by z to the first power. Guys, it's z divided by himself. Anytime in math you divide something by itself, what does it equal? 1. So they cancel out to 1. There's no more z's. We don't even have to know what z is to know that z divided by z is 1. And that's your final answer. And in your final answer, you should only have x's in one spot, y's in one spot. You don't want an x in 2 places. That's not simplified. All right, look at example 5. Another division problem, right? No adding and subtracting. So all we're going to do is divide. Divide your numbers, divide your x's, divide your y's, subtract your exponents. All right, so the numbers, negative 16 divided by 12. Well, guys, unfortunately, negative 16 doesn't divide by 12. So treat it like a fraction that needs to be reduced. What's the biggest number that divides evenly into 16 and 12? 4. So negative 16 divided by 4 is negative 4. 12 divided by 4 is 3. You just reduced the fraction. So we still have a top and we still have a bottom. All right, let's do x's. X to the third divided by x to the first. 3 is bigger, so it'll go back on the top. 3 minus 1 is 2 on the top. So x squared. Now we do our y's. Y to the 8th divided by y to the 4th. Well, 8 is bigger, so 8 subtract 4 is 4. Put it back on the top. So the only thing that ended in the bottom was 3. Everything else went to the top. Everybody good? All right. So again, the quotient of power rule says when dividing the same base, subtract your exponents. And put it back where the bigger exponent was. And remember, take the big exponent, subtract the small exponent. You don't want to create a negative exponent. Because one of the rules we have is how we get rid of negative exponents. We don't want them, so don't create them. All right, one more rule. Let's do the third rule, and then we're going to have to stop. All right, guys, this is the third rule. It's like the last main rule, and I'm telling you, for whatever reason, I feel like this is the rule where everything was fine. And then we throw this rule into the mix, and now everything goes out the window. Everybody starts to get confused. But in reality, each exponent rule by itself is pretty simple. I add exponents, I subtract exponents. We're going to see what we do with these ones. The individual rules are simple. It's when you start getting problems that involve all the rules. You can get confused, like, wait a minute, should I be adding them here or subtracting them here? Should I be multiplying them here? What should I be doing? When you start putting all the rules together is where it can get confusing. All right, so rule number 3, the last main rule is our power to power rule. It's when something already has an exponent and then you raise it to another exponent, power to power. What the heck do we do? All right, let's do it the long way first. So guys, this is x squared. Clearly, it already has an exponent of 2. But then you're going to raise it to another exponent of 4. So that's the power to power. Well, think about what this means. This 4 tells you to multiply x squared by itself 4 times. So that literally means x squared times x squared times x squared times x squared. And then each one of those x squareds means x times itself twice. So in reality, how many times do you actually end up multiplying x by itself? 1, 2, 3, 4, 5, 6, 7, 8. That's x to the 8. So what would have been a faster way to get to that answer when you had x squared raised to a power of 4? Multiply your exponents 2 times 4. So that's going to be our power to power rule. The power to power rule says that when one exponent is raised to another exponent, you multiply the exponents. But guys, be careful. Because if there's a number in the problem, then you have to raise that number to that power. And now you're back to multiplying something by itself so many times. People start to multiply numbers with exponents now, and we never want to do that, okay? All right, so look at this one. So if I had 4 to the 5th to another power of 2, guys, that's going to be 4 is my base, multiply your exponents, 5 times 2 is 10. That's 4 to the 10th power. And since we have a known value as our base, you could ask your calculator what that is. I did, and I wrote it down because it's pretty darn big. It's 1,078,576. Again, because the base was a known value, we could take this problem one step farther. But here we have to stop because we don't know what x is. All right, here we go. Guys, look at this one. 5x to the 4th, all raised to a power of 3. PEMDAS would tell us to do inside the parentheses first. But guys, inside the parentheses is 5 times x to the 4th. I can't do that any more than it already is, right? So now the power of 3 on the outside says everything on the inside has to get raised to that power of 3. There's no adding and subtracting, turning this into some type of FOIL problem. It's literally make sure everything in here gets raised to a 3rd power. So guys, think of it like this. 5 is a number. So when you raise it to a power of 3, that's 5 to the 3rd. That's 5 times 5 times 5. That's 125. And now x to the 4th, because really that 4 is only on the x to the 4th raised to another power of 3, that's the power to power. That's what we multiply. That'll be x to the 4 times 3, 12. So a lot of students write 15 here because they're like, oh, power to power, multiply. But 5 isn't an exponent. It's not like you're multiplying exponent to exponent. 5 is a number. 5 to the 3rd is 125. So I find a lot of times, I just tell students to do this because this is the rule that confuses everybody. 5x to the 4th to the 3rd, guys, just write it 3 times. 5x to the 4th times 5x to the 4th times 5x to the 4th. And then you can see it. Oh, it's 5 times 5 times 5, it's 125. X to the 4th times x to the 4th times x to the 4th. Now all I gotta do is add my exponents. 4, 8, 12. Done. So if you ever get caught, I'm telling you, expanding it can really clear any of the own questions that you have up. All right, look at this one. So everything inside the parentheses, right? I can't do anything with it. There's no adding and subtracting. I have no like terms. I can't multiply any of this together any more than it already is. So on the outside, there's a power of 3. So that just means everything inside here has to get that power of 3. So give it to everything. So -2, guys, is a number. So -2, and now you've given it a power of 3. So guys, that's literally -2 to the 3rd power. That's -2 times -2 times -2. That's -8. And make sure this is how you ask the calculator to do it if you're a big fan of your calculator. All right, keep that inside the parentheses. All right, now take x to the 6th, something that already has an exponent, give it another exponent of 3. This is where we multiply, power to power. This will be x to the 6 times 3, 18. Y to the 7 to another power of 3, 21. 7 times 3. Now, I just think of it as z. I know he has an understood exponent of 1, but when nothing's showing, you're just giving it a power of 3. So now it's z to the 3rd, which would be the exact same thing as 1 times 3. But I'm always afraid that people are going to do 1 and 3 and they're going to add them and get 4. So I don't even say it. We just give it a power of 3, now it's the power of 3. All right, but again, if you get there and you're like, ah, damn it, what did she say to do? Then guys, just write it 3 times. Do -2, x to the 6th, y to the 7th, z, times itself 3 times. And then you can just multiply your -2's, add your exponents, and you will get the exact same answer. So if you're in a jam, sometimes it helps to expand this. All right, last one. All of this is being raised to a power of 4. And again, there's no adding or subtracting. So all I have to do is give everything in there a power of 4. So -3 is a number, raise it to the 4th power. Guys, that's -3 to the 4th power. That's -3 times itself 4 times. So if you want to use your calculator, you better type this. If you type that, it does it wrong. Because this, your calculator doesn't know to include the negative. So you have to write it in parentheses. You should get positive 81. -3 times itself 4 times is positive 81. And now we give this power of 4 to all of these powers, so we're going to multiply all of them. It'll be x to the 4 times 4, 16. Y to the 5 times 4, 20. And then z to the 7 times 4, 28. And you're done. But again, if you get confused, then write this 4 times and just treat it like a multiply problem. Multiply your numbers, add up all your exponents. All right, so the power to power rule says, when one exponent is raised to another exponent, this is when we multiply the exponents. All right, but I did put a note, guys. I always get worried about this because it's going to come back in chapter 5. So before, we had a problem like this in our homework already when we were doing the imaginary numbers in FOIL. Guys, the minute they put addition inside the parentheses, You are no longer allowed to do that. You cannot distribute an exponent over addition or subtraction. None of these had addition or subtraction, so it's beautiful. But just remember, when we get back to a problem like this has to be written twice, and the only way to multiply over all that addition is to distribute. So it's a FOIL problem. So I don't want you to forget that. Don't get in the habit of distributing all these exponents and get to a problem like this where addition or subtraction is involved and start distributing your exponent, because you can't do that. These ones have to be expanded and FOIL. Are we okay? All right, so guys, I'm going to stop there. So again, I hope you're sitting here like, God, Hardy, I remember these rules, but I'm telling you, every year I don't review them. Chapter 5 takes a really ugly turn. So hopefully we'll spend a nice, easy week just reviewing our exponent rules, nice and easy. Quiz on Friday, nice, easy quiz grade. We'll start chapter 5 on Monday, okay? All right, so guys, I didn't get to finish the last 2 rules, so save these notes. I'll pick up there tomorrow, and then we'll go, all right? So your homework. Guys, if nobody started the homework yet, I'm going to edit it right now. I want to take off. I put rule number 4 on your homework, thinking we would get to it, and we didn't. So I want to take the rule number 4 problems off your homework. So if you didn't do it yet, that's great. Give me a few minutes before you start it, all right? Just, I want to get that off there. All right, if I say your name, you are good. Unless you have any questions, you can stay in chat. All right.